Hey there, geometry peeps. This is your special right triangles notes. Now, the first type of triangle we're going to examine here is a 45, 45, 90 degree triangle. So that means my 90 is there, and my other two angles are 45 degrees, which creates a right isosceles triangle. Now, a certain relationship exists between the sides of a triangle of these degrees, of this relationship. The sides are in a ratio of 1 to 1 to root 2. And that comes from cutting a square in half, and that same pattern or relationship always exists. So it's 1 to 1, and your hypotenuse is always going to be root 2 longer, root 2 longer. Now, when we're given problems with these angle measurements, we can use this reference triangle to find the missing side length. So think about back in the past, we always used Pythagorean theorem. If we knew two sides, we could find the third. Any two sides of a right triangle, we could find the third. But now, with these special triangles, we actually only need one side and we can find the other two. So, for example, this first one, we're going to say we have a 45, 45, 90 triangle. I'm going to tell you this side is 7. This is x and y. We're going to use our reference triangle to solve for y. Now, if these are my angle degrees, it's always the same relationship that exists. 1, 1, root 2 longer. So if this is 7, we know this side is 7. This is your isosceles triangle. Those sides are congruent. And your hypotenuse is always root 2 longer. So this would be 7 root 2 for y. So x equals 7 and y is 7 root 2. So when you're given one of the legs, these problems are actually really easy because you know the other leg is congruent and the hypotenuse is always root 2 longer. Alright, but what if we don't give you the leg? What if I tell you this is 16, this is x, this is y? Now we know 16 is the hypotenuse, and we know x and y are the same, but we don't know what they are. Now, if you take a look at your reference triangle, you can see that 16 matches up with root 2. So to get from here to here, we multiplied by root 2. So to get from here to here, we have to divide by root 2. So we know this matches up with this. So we know 16 equals x times the square root of 2. Alright, now I'm going to solve for x. So we would divide by root 2. So x equals 16 over root 2, but we can't have a radical in the denominator, so we have to rationalize. So I get 16 root 2 all over 2, which gives me 8 root 2. So that means my legs are 8 root 2, 8 root 2. Now, I did quite a bit of algebra here to solve it for you, but as we do more and more of these problems, you're going to recognize patterns and relationships, and you're going to be able to do them at the snap of your fingers. All right, you should be able to do them really quick. But for now, here's the algebra behind it. We knew in our reference triangle, 16 matched up with x root 2, so I could divide by root 2 to solve for x. Or think of it as to get from here to here, I multiply by root 2, so I'm working backwards. I took 16 divided by root 2. Alright, so with 45, 45, 90s, there's really only two situations that can happen. I give you the leg, this leg's the same, multiply by root 2, or I give you the hypotenuse, divide by root 2, and you know both of the legs. Alright, so that's our first triangle, 45, 45, 90. Now for our second triangle, we have a 30, 60, 90 degree triangle. So we have a 30 degree angle, a 60 degree angle, and a 90 degree angle. Now, this results from cutting an equilateral triangle in half. Okay, so if my equilateral triangle came down like this and this, we could do Pythagorean theorem, and the ratio of these sides is 1 to root 3 to 2. Okay, so across from the 30, I like to call the golden child, because that's our x. That's the easiest piece that we're always going to be trying to solve for. Once we know our x, the problem's simple. We know this piece opposite the 60 is root 3 longer, and the hypotenuse is always twice the length of x. Alright, so the 1 root 3 to 2 is the relationship that exists there. Alright, so with the 30, 60, 90, there's really three relationships that can exist. The first relationship is I give you the piece across the 30. The second relationship is I give you the hypotenuse. The third relationship is I give you the piece across from the 60. So let's look at each of these. So let's say this is 30. Now again, you have to focus on who's across from what angle. Which side is across from the angle, not necessarily how I flip it or draw it. So across from the 30 is 9, and we're going to call this x and this y. So solve this for x and y. Now again, when you're given the piece across from the 30, that's the easy one, because I know what x is. So I know this is x, but root 3 longer because it's across from 60. And then this one is double my x value. So 2 times x, which in this case is 2 times 9, is 18. So x is 9 root 3, and y is 18. All right, so that's the good one. Now the second one is, let's call this one 30 and this one 60 this time. And this time I'm going to give you the hypotenuse is 80. The hypotenuse is 80. All right, we're going to call the other two x and y. Now, we're always going to start by finding the piece across from 30. That's the important piece, because once I know that, it's just straight up multiplication. All right, so let's look back at this one. To get my hypotenuse, I took the piece across from 30 and I multiplied by 2. So to work backwards for my hypotenuse, I'm now going to divide by 2. Or another way to think about it is, in your reference triangle, here's my hypotenuse, here's my hypotenuse. So I know that 80 and 2x match up, so 2x is equal to 80, and now I can use that equation to solve for x. So however your brain thinks about it. So now that I know x is 40, I know my piece across from 30 is 40, and then to get my piece across from 60, I take my x and it's root 3 longer. So I take my x and it's root 3 longer. Alright, so the first example, I give you the piece across from 30, straight up multiply by root 3 and double. If I give you the hypotenuse, we have to divide by root 2 to find the piece across from 30, and then multiply it by root 3. Alright, and then lastly, I could give you the piece across from 60. The piece across from 60. So what if I told you this was 15 units long? Again, we always want to solve for the piece across from 30. Now, I keep calling it x in this video, but I could call it anything. M, N, Y, Z, whatever. So, now let's think about this. I'm given the piece across from 60. To get from here to here, I multiplied by root 3. To get from here to here, I multiplied by root 3. So now to work backwards, I'm going to have to divide by root 3. Or another way to think about this is, in my reference triangle, x root 3 is across from 60. Here, 15 is across from 60. So I know x root 3 equals 15. So I'm going to have to divide by root 3 to get my solution. Okay. Again, I can't have a square root in the denominator. So I multiply, and I get 15 root 3 over 3, because 15 times root 3 is root 3. Root 3 times root 3 is 3. 15 divided by 3 is 5 root 3. So I now have solved for my piece across from 30, which is the important piece. So now to get to my hypotenuse, I take my x and I double it. So 5 root 3 times 2 is 10 root 3. Okay, now, don't get so hung up on the root 3. Root 3 is just a value. It's a number. Alright, so to say it's root 3 longer, the root 3 doesn't always have to go across from 60. That's the relationship that exists. But the number itself can appear anywhere. Alright, that's all I got. See you later.